Hello, my lovelies. It's Susanna, and today I want to show you how to solve this problem. The three red squares in the figure each have an area of 16 square centimeters. We can see these three red squares here. Together, they form a rectangle inside the larger rectangle. So these three red squares form a rectangle that lies inside this larger rectangle here. Two corners of the red rectangle are located at the midpoints of the shorter sides of the large rectangle. So this corner here and this corner here, they are located at the midpoints of these shorter sides of this large rectangle. What is the area of the large rectangle? Okay, so we want to find the area of the large rectangle. Let's call this area A, and how can we find it? We would need the length of this side here and the length of this side here. And then we only have to multiply these two lengths. What about this length here? They told us that this here is the midpoint of this side here, which means if I call this part down here x, then this part up here has the same length, so I have x here as well. So this side here would be 2x in total. So I can take 2x in here already, and then we multiply it by the length of this side here. This side is also divided into two parts. We have this part here and this part here. I call this part A and this one B, and the length of the entire side is A plus B then. So I have to write this in parentheses that I multiplied by A plus B. Like this, we can find the area of the large rectangle. The only problem is we don't know x, we don't know a, and we don't know b. So we have three unknowns in here. But let's keep this formula in mind that this is our plan. And if we take a look at this large rectangle here, these three red squares lie inside this rectangle. And here we have a triangle, and here we have another triangle. Here is a small triangle, and here as well. So we can use these geometric shapes to find the area of this rectangle as well. As I said, we keep this formula in mind, but let's try and find a different way to find this area here of this large rectangle. Let's start with the red squares. They told us that each square has an area of 16. So we have 16 here, and here as well. So these three together are 48 then, plus the area of these triangles here. Let's start with these larger triangles. It looks like they have the same area. How can we prove that? We can show that these two triangles are congruent to each other, because then they have the same area. So let's take a look at angles and sides of our triangles. Here we have a right angle because of our large rectangle. Same here. Here we have a right angle as well. So we have right triangles. And here we have the length of x. Same thing here. This is also the side of this large rectangle, so we have the length of x here as well. And what about this side here? This is a special side in our right triangle because this side lies across the right angle, so this is the hypotenuse of our triangle. And this side here is one of the sides of this red rectangle. So this side has the same length as this side here. And this side is part of this triangle down here and also lies across the right angle here. So this is also the hypotenuse of this triangle. So we've just shown that this side here, if I call this y, has the same length as this side here, which I can also call y then. And this is enough to show that these two triangles are congruent to each other, because in right triangles, you only need to show that the hypotenuse in both triangles has the same length, and that one of the other sides has the same length. And then these two triangles are congruent to each other and have the same area. Okay, so we can use that these larger triangles have the same area. For the same reasons, these small triangles also have the same areas. Okay, let's add these areas then. Let's start with these larger triangles. We have two of them, so we have 2 times. And for the area of this triangle here, we need the base, which is A, multiplied by the height, which is x, and divided by 2. And for the small triangles, we have a right angle here as well. We have our x here as well. So we have 2 of these small triangles. So we have 2 times, and same formula. We take the base, which is b, multiplied by the height, which is x again, and divided by 2. Okay, let's simplify this a little bit. We have the 48 here plus this 2 cancels out, so we only have a times x, and this 2 cancels out as well, so we only have b times x. This is all we can simplify. What have we found now? This here is a formula to find the area of the large rectangle. But we already had such a formula at the beginning, do you remember? So if we take this new formula with us, go back to the beginning where we already had a formula to find the area of the large rectangle. But that is great. We have 2 different formulas for the same thing. And because both calculate the same thing, we know that this here has to be the same as this here. So we can write it as an equation. We can take this part here, and it has to be the same as this part here. And now we have one equation, and maybe it helps us. So let's see what we can do with this equation here now. We have many variables here. Maybe let's bring all variables to one side. So let's subtract here ax to bring it to the left side, and let's subtract bx here in the same step. So we want to subtract these things on both sides of the equation. So that here we have this part that was there already, so it stays here. We subtract ax, and we also subtract bx, and on the other side we only have the 48 because all of this disappears. Okay, maybe so that we can simplify things a little bit, maybe let's get rid of these parentheses here by multiplying the 2x by everything here inside. So we get 2x times a first, which is 2x times a plus 2x times b, which is 2x times b, minus ax minus bx, and the 48 on the other side. Let's simplify this. We have a part with xa here and a part with ax here. This is actually the same thing, so I prefer to have it in the alphabetical order, so I would like to switch these two letters, that we have A first and then the X, because then you can see it. Okay, here we have 2 of AX and we subtract 1 AX, so in total I get 1 AX as a result, plus, and we have the same thing with the XB and BX. I prefer the alphabetical order, so let's switch these two here. Let's write the B first and then the X, so that we can see we have 2 of the BX here, and we subtract 1 of them, so that we get 1 BX as a result, and on the other side the 48. Okay, now we have an X in here and X in here. We can factor out an X. So let's do this. We have X that we want to take out. So what is left in the parentheses then? We have the plus here in between. And here, if we factor out this X, only A is left. And here, if we factor out the X, only B is left. And on the other side, we have the 48. Okay, this is all we can do here, but does this here look familiar to you? If not, let's just go back to the beginning. So let's take this here with us, what we've just found. This is what we have here. And this was what we had at the beginning. This was our formula to find the area of the large rectangle. And look at this. This looks super similar to this thing here. We have X here, also here. We have A plus B here, which we also have here. The only thing that is missing is this 2 here. But this is an equation. We can multiply both sides of the equation by 2 if we want to, so let's do it. We multiply by 2 here, same thing on the other side. On the left side, this is exactly now this formula. And the other side, we can calculate this. 48 times 2 is equal to 96. So the area of our large rectangle is 96. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of our next videos. Take care!